going to throw onto the multiple CPUs. Now I would like to run 3000 by 3000 matrix multiplication, compile it. It takes some time. It takes some time. Okay, let's hope so. Probably it's in pending. Okay, no, it's, I think it's compiled. Okay, it's compiled. Now try to run it whether it's available. It will run. Node count, I like to provide how many number of CPUs you need is okay. Imagine I would like to provide now as 16. Let's see whether are available or not. 16 nodes. Yeah, submit. Let's see whether it will run or not, because based on the availability we are using the supercomputer, right? Supercomputer is there in CDAC Bangalore, that is called Param Utkarsh. I access it through my login. This is the way I would like to use. Why we are deal with all this computation is called high bandwidth and low latency operations. uh, High bandwidth and low latency operations we have to perform. See, it's not running, I think so. Again, I like to run, I like to execute by limiting to 8. Let's see whether it's running or not. Job submission is in progress. Okay, fine. Okay, still the job has to load. Okay, yes. Okay, it's, see, it's running. Now it's in pending status. Already other one is in yeah. Oh, see, both are submitted. See, earlier I given 16, right? Students, you are observing or not? See, here 16 are there. Just okay, till now what I discussed is the one like the basics of the HPC. We are not completely discussed about the programming, just outline. Okay, how you are going to motivate towards this supercomputing for your BTech level problems, all the things for petroleum engineering related projects. Also, you can apply these supercomputing uh, power. So now see, running 16. Yeah, 16 is there. Can you see how many CPUs are used? See, these are the CPUs and GPUs. 1, 2, 3, 4 are used, and other machines 2 are used. See the output. What is the matrix multiplication size, students? Yeah, dear students, please. What is the matrix multiplication size? Yes, someone please mention, please.
3000.
3000. See the output. Can you compute manually? No. Will you compute through other programming? No. Only we need some supercomputing power. Then only you'll get the output. It's running. It takes some time because it is around 3000 dimension matrix multiplication. See. Yeah. This is the output you will get. This is the matrix M1 is there, M2 is there, and it's computation. Okay. This is the output you got. Yeah, now I think you realize that the power of the computing within a fraction of seconds, okay, within milliseconds, you are generated this output. So 3000 matrix multiplication. Okay, that's there exists the internal programming logics, create the matrix, display C language related matrix multiplication that you have to manage among the multiple. This is the internal programming called MPI programming. With the help of this programming, you are going to work with supercomputers, because you have to prepare a job. The job has to run. The job has to run on multiple CPUs, throw onto the multiple CPUs, throw onto the GPUs. Okay, then the outputs are computed. All the outputs you have to accumulate, and the result you have to generate. So this is the other kind of interface. Okay, I utilize for generating this output. This is one command based. Yeah, here also we can display. Okay, so yeah, that's the one. Okay, let's move on to okay. So now we have to go with the parallel computing. Yeah, early serial computing. Okay, one person takes 15 hours of time. Imagine if 15 persons will work together, saves the time and saves the larger problems. You have to break the problem into number of subproblems, and you have to throw onto the multiple CPUs, and you can run. And parallelism is necessity for today's computing. Yes, now it's required because even cloud infrastructure, all the things they are supported this is parallelism. Okay, concepts. What is the that is the reason you can call as parallel programming. Parallel programming is possible by using the uh, MPI, Open MPI, all these things. So now parallel processing, parallel programming, and parallel computing. Okay, so these are the three terms you have to know individually. Parallel processing is the one processing multiple tasks simultaneously and multiple processors. Mm, yeah, and parallel programming, parallel computing we have to use. So parallel programming we have to apply. Parallel programming is the one software methodology used to implement parallel processing. So okay, before that you have to know about okay how the instructions are fed to the machine. Only a single instruction, single data, single instructions, multiple data like this. Okay, because only one instruction earlier they fed. Now it is multiple instruction, multiple data, multiple instructions and multiple data, all has to run. That is the reason most current supercomputers, network, parallel computer clusters and grids, multi-processor SMP computers, multi-core that is based on multiple instructions and multiple data. Okay, these are some of the Param computers. See how these Almaras kind of structures. Okay, that is called Param Padma is the one computer. So yeah, parallel programming is mainly based on, as I told already, a problem is there. We have to break the problem into number of subproblems, and all the subproblems has been thrown onto the CPU and GPUs, combined together, generate the results. So that is the reason. Okay, imagine if you take any problem, your problem has to be break into number of subproblems, and all that will communicate and all that form into the clusters. This is called agglomerative clustering. Agglomerative clustering is the one like yeah, generally where we have to group. That one you can say is clustering. One of the type of clustering is called agglomerative clustering, and then you have to finally map to its appropriate. So okay, this way you have to think and break the problem into number of subproblems. Here there exists the partition. Partitioning is based on I think you people studied about recursive functions, non-recursive function, and all. Okay, that is recursive functions. Okay, that is function that is calling internally, and all. So C language related, all they think about this kind of partitionings. So if you like to find the sum, okay, you have to go for the recursive approach. Okay, and decomposition, breaking that into number of small partitions. Yeah, this is the one mainly used for market basket analysis. This is the one mostly. Okay, because all these are called the items. These are the database transactions from all these. What are the most frequently brought items? Yeah, imagine by seeing the first diagram, we have a list of transactions are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transactions are there. If you think about these 10 transactions, by imagine, yeah, Flipkart or Amazon, or can you imagine the data size, how many number of transactions, and how many number of items? So out of all the items, what are the most frequently brought? Okay, it's very difficult to analyze. Where we need a supercomputer to analyze, where we have to break it into number of some, and okay, that is the reason this is item set is generated. Okay, similarly we have partitioning the frequencies based on the frequencies. Okay, how to get the frequency. Here, what is the meaning of data set transaction is a set of transactions. Out of that, most frequently bought item sets that are displayed here. And similarly, there exists the domain based on the domain also you have to decompose. Yeah, these are the different strategies in in the problem solving. Okay, these all theoretical aspects you have to provide in terms of programming to the supercomputers. Okay, agglometric clustering. Okay, I already discussed about the clustering, agglometric clustering you have to do. And finally, once a problem has been decomposed into concurrent tasks, the task must be mapped to processes. Mapping must minimize overhead. Minimizes overhead is a trade-off game. Ultimately, you're going to get the performance. That is load balancing. Ultimately, you're going to get the performance. So this is the strategy you have to apply. This is the strategy you have to apply for towards the programming also. So yeah, this very important. Now you have to know about, once you have only one machine with shared memory is there, you have to go for OpenMP programming. OpenMP. Once you have machines connected via network and have no shared memory, then you have to call MPI programming. Or sometimes if you work with accelerators like NVIDIA or Intel or AMD, then you have to know about this programming, CUDA programming and OpenAct programming and OpenMP programming and all. If you are working with a heterogeneous collection of these kind of things, you have to go for this program. So just move on to this particular program. This program is called the MPI program. Just I would like to analyze this program here for your understanding. Why MPI? When you are dealing with multiple machines, okay, on machines connected by a network and have no shared memory. Obviously, machines are all connected. How many number of CPUs I use for this program is 8. Okay, so all that are connected, all that are all that are parallelly programmed, meaning that the program is breaks into multiple pieces where exists the partition, there exists the clustering and all the things. So the programming, MPI programming, see here, this is the one MPI programming. Initially, I want to initialize nothing, some number of yeah, based on the size of the matrix, I would like to define the number of the nodes, okay, based on the nodes all that are parallelly run, okay, for getting these outputs. So these are the programming things, okay. uh, Tomorrow programming will be covered by Professor Kishore uh, from AP. Okay, he will take the session on the programming part. Now today I would like to focus more on this particular introduction and what way the programs are connected now. Once you have the supercomputer, you have to write some program also to throw this program onto the multiple CPUs. Such programming you can use is MPI, OpenMPI, and all. When multiple machines are there, you have to go with MPI. Yeah, see, this is a OpenMP program. OpenMP is meant for a single machine with shared memory. Only single machine. If you are working with only single machine, you can go with this program. Okay, that another program is called MPI. This is the one for multiple machines. Okay, multiple machines. So this is the one where we have to use the scatter this work onto the number of nodes, and outputs you have to gather the outputs. Okay, there exists the logic. Okay, because you have to define the number of what the array size is 100. Okay, based on the size, the process you have to define. So scatters the data onto the number of processes. After scattering, it will generate through gather method. Okay, once you will open the connections, you have to close the connections. A program, MPI program for multiple machines. Okay, now I shown, that is the reason I shown around 300 by 300 matrix multiplication. Yeah, and heterogeneous programming, this is a bit complex when you are dealing with advanced computing related machines. So you can use this heterogeneous programming too. And OpenAC is the meant for specific GPU. Okay, meaning that if you are working with NVIDIA, we have the CUDA programming. If you are working with Intel, other program. Okay, this is a OpenAC programs, okay, really based on the GPUs. So yeah, so this is a simple diagram. From this diagram I understood that parallel processing is there. Imagine okay, LOD is there having multiple things, multiple ends, parallel processing is there. So this there, okay, but you have to go with parallel processing uh, in the supercomputers too. Yeah, students, are you followed? Yeah, any questions from this
No, sir, no.
discussion?
No, sir, एकदम question नहीं. No, sir, we have no any question.
Yeah, dear students.
Students, are you there?
Yes,
Yes,
ma'am.
he's asking you something, you should answer.
Any questions? Do you have any questions from your end based on this discussion? The outline of the discussion is the one like computing power,